Hello everyone, my name is Hemu and we are here for the Palo Alto Firewall PCNSC training with regards to the Palo Alto Firewall perspective. Okay, so before going into our discussion, let me tell you, this is the guy's contact number which belongs to me. So you can able to ask any of your queries on this number. You can able to text me on WhatsApp. Either also you can able to call me. And my availability is Monday to Friday, 9 p.m. to 10 p.m. IST. This is the time. That time you can able to call me and we can discuss your doubts. Apart from other timings, you can able to text me anytime. And whenever I used to get the time, I used to reply. Okay. This is my email ID. If you want, you can also write the emails to me and I'll reply over the emails as well with some screenshot, whatever issue you are facing, right? This is my LinkedIn profile link. So you can also, if you want to follow, you can follow me on LinkedIn. Now from here, the most important thing is start, right? You can see we have a application, guys. Okay. And this is the application from where you will get all your recordings with lifetime access. Okay, so for Android users, what you have to do, you have to basically go to into this particular link and you have to download our application in your mobile phone. For iPhone user, you have to go to into this particular link. You have to download the application and you have to put our organization code, which is VNCPH, and you have to log in. Apart from these mobile apps, we do have a web browser. Means you can able to access our recording videos through the application through the laptop as well. What you have to do, you have to open any browser, Mozilla Firefox or Chrome, and you have to visit this particular URL, https web.class+app.com/login, and it will ask the organization code, which is VNCPH. Now, when you will create an account into our portal, right? So what you have to do, you have to use your mobile number. So let's suppose if you are from India, then use your Indian mobile number and you will get the OTP, and you have to basically, when you will put that OTP, you will able to log in. For the international peoples who don't have the Indian mobile number, what they have to do, they have to basically create the account using the email ID. Email ID option is also there. I'll basically share one document as well on that, how you can able to create all these things. So what this particular link I have already provided you guys, even though in your WhatsApp group description also I have put the same thing. So what you have to do, you can basically go through with, you can basically go into these links and try to download the application and create your account. What you need to do, you have to download the application and you can create the account. Okay, just give me 1 second, guys, please. Okay, so guys, now let me tell you what are the topics I'm going to discuss in your first class. So in your day one, we will see what is firewall, because guys, I will start your training from basics to advanced. So like I will cover each and every aspect of it. So we will first discuss what is firewall, what is stateful inspection, what is stateless inspection, Palo Alto firewall history, Palo Alto firewall product portfolio, Palo Alto firewall operating system, Palo Alto firewall hardware series, VM series, SP3 architecture, and initial access. Packet flow I will not discuss today because packet flow is a very big topic and I need around 2 hours or 3 hours of time to complete. So that thing I will cover in next lecture. Okay. So these are the topic which I am going to discuss. So now let me start with the first topic, which is what is firewall. And I hope everyone know what is firewall. So a firewall is a software or hardware based network security system. Means this particular device called firewall, it may be a software based device or it may be a hardware based device. Network security systems that controls the incoming and outgoing network traffic by analyzing the data, packets, and determining whether they should be allowed through or not based on the configured rule set. Now let's try to understand each and every line here. So let's suppose I have a one architecture where I have a firewall. I am just going with a very basic diagram. I have one firewall here. I have one PC here, PC1. This firewall have a connectivity with the internet service provider ISP, and here I have one of the server over the internet. This is server. Let's suppose this server is hosted on TCP 443. And let's say it's a Facebook server, just for example. This particular interface, let's suppose, is Ethernet 1x1. And this interface is Ethernet 1x2. Let's say this interface is a part of outside zone, and this interface is a part of inside zone. What is zone? Everything I am going to describe, even though I will also cover what is inside, outside, and all. Okay. Inside means this is a network where you are connected as an employee or your servers are available. Means inside represents the LAN network of your organization. And after that we have a outside. Outside represent the interface which connects us with the internet, or it connects us with the internet service provider or WAN link. Okay. So as I have mentioned here, let's suppose this particular PC wants to communicate with this server. And let's suppose on this PC, I have opened the web browser and I have typed www.facebook.com. Now guys, what are the series of activity happen on this particular PC? Can you tell me what is the first thing this PC will do? After typing this www.facebook.com, what are the first thing this PC will do? I got the answer DNS. That's correct, Tabrez. That's correct. What it will do? It will do it will perform the DNS lookup for facebook.com to get the IP address. So DNS lookup will happen first. And after that, what is the next activity? Now let's suppose this PC got the IP address of this server. Now what is the next thing which this PC will do? What is the second thing it will do? Now it will start the most important thing, which is TCP three-way handshake. Because once TCP three-way handshake will complete, because this server is hosted over HTTPS. So now what is the next thing this particular PC needs to do? With the HTTPS website, what will happen now? The third thing it will do is start the SSL handshake. And once SSL handshake will complete, now in fourth step, they will basically access the data. Now here they will exchange some application data. Means your actual users data will start after DNS lookup, then following the TCP three-way handshake, following the SSL handshake, and once all these three things will complete successfully, your this PC will start exchanging something over the Facebook. I hope this particular things is everyone understood, right? When we type a URL in a web browser, these are the series of activities performed by your PC. Now, how this TCP three-way handshake happens, how SSL handshake, I'm going to cover in depth. Don't worry. Okay. Now, so guys, tell me one thing. When this particular traffic reach to the firewall, first time, let's suppose after DNS lookup, it start the TCP three-way handshake and it has sent the very first packet, which is TCP SYN packet towards this firewall. Now, As I have mentioned here, a firewall is a software or hardware based network security systems that controls incoming and outgoing network traffic. So first of all, we need to understand what is incoming and what is outgoing. So guys, let me tell you now. Incoming traffic means the traffic which is coming towards your network. Let's suppose there is a one PC available over the internet. Let's say this is PC 10 over the internet, and you have one server in your LAN. This is the server one you have in your LAN area. Now let's suppose this PC 10 wants to communicate with this server, so he will forward this data like this. Now, with regards to this firewall, if you will see, this traffic is coming inside your firewall. So this type of traffic is known as incoming traffic. And when this PC1 has communicated with this particular Facebook, so what he did, he has just forwarded this traffic towards, through your firewall towards the outside, which means this is a outbound traffic. Means the traffic who is leaving your organization boundary is known as a outgoing traffic, and the traffic who is coming inside your organization boundary is known as incoming traffic. And this particular device called firewall, what it used to do, it used to basically control this particular incoming and outgoing traffic. Control means, what do you mean by the control? What do you mean by the control, guys, here? Let's suppose I want to control someone, then what I can do, or what this firewall will do here? Control means it can either allow the traffic or it can either deny the traffic, right? It can able to perform these two activities. Allow the traffic or deny the traffic or inspect the traffic. That is also one more term, but I'll cover that later. So your firewall, what it used to do, it will basically control the incoming and outgoing request by analyzing the data packets. Guys, do you know? Let me just write down a couple of terminologies here. Let me use this green color. Guys, do you know what is segments? And what is datagram? What is packet? What is frame? I hope all these four things is everyone aware about that. Segments means, let's suppose your PC1 and this server is communicating over TCP. So at your layer 4 of your TCP IP model, we have a segments. If this PC and this server communicating, let's say they are using UDP, that time at layer 4, the data format is datagram for UDP traffic. Then we have a packet. Packet means this is a layer 3 information. Your IP header is known as a packet. So packet contains your segments. And then we have a frame. Frame is a layer 2 header. Okay, these are just data formats according to your TCP IP or OSI model. The very basic thing. Okay, now one more thing I want to cover here. Guys, do you know what is ingress interface and what is egress interface? Let's suppose this PC wants to send this packet. This is your packet number 1 towards this server. Now, which interface is ingress and which interface is egress for this particular flow? Ingress interface means the interface where packet coming inside your firewall. is known as ingress interface. So here Ethernet 1x1 is a ingress interface, and Ethernet 1x2 is a egress interface, the interface through which your packet is going out. Because Ethernet 1x1 it will use for sending the, sorry, Ethernet 1x2 is ingress here, Ethernet 1x1 is egress here. So the interface who received the packet is become the ingress interface, and the interface who send out the packet is known as egress interface. Just remember these terms as well. Okay, now so our firewall is a software hardware based network security system. Means this particular device may be a software, maybe hardware. Means guys, hardware means we have a physical appliance. Hardware means it is a physical appliance who is dedicatedly designed for doing the firewall activities, like he will allow the traffic or he will deny the traffic. Software based firewall. Can you guys send me some example of software based firewalls? What are the software based firewall examples? So guys, you have heard the name of Windows Defender, Windows Firewall. You have heard the name of Quick Heal, Kaspersky, right? McAfee, Norton. These are the some antivirus software which may you have used in your laptop, right? All these are the software based firewall. Let me just show you here. If I'll go into my control panel of my system, security, Windows Defender, this particular Defender is like a software based firewall. Okay. And if you will go into advanced settings, you can say we have these inbound rules and outbound rules. These rules basically we have written as the software level. These are the some example of software based firewalls. And your Palo Alto is a hardware based firewall. Okay. Now, so if somebody asks what is firewall, the very simple definition: firewall is a device who can control incoming and outgoing traffic by analyzing the data packets. Means analyzing the data packet, which means what it used to do, it will analyze. So at your packet we have the source IP address and we have the destination IP address. At segment we have the source port, we have the destination port, and even though at packet we also have a layer 3 protocol number. Guys, what is the layer 3 protocol number for TCP and UDP and ICMP? TCP is 6, UDP is 17, and ICMP is 1. Just remember. So guys, we have just mentioned here it will control incoming outgoing requests. See how it will control. So what it will use to do, it will control by analyzing the packets. What it will check in the packet, it will check your source IP address, destination IP address, layer 3 protocol number, source port, destination port. These are the information it will use for allowing the traffic, for denying the traffic. And how it will basically make the decision, because in a firewall we have a rule set. If you have configured, if you know about the access control list, means ACL is a combination of deny and allow statements, and these statements have source IP address, destination IP address, layer 3 protocol number, source port, destination port, right? We will combine them and we will make the decision. Because why it will basically use this source IP and destination IP and source port details? Because This particular server has one IP address. Let's say it has, this is the IP address available on this Facebook server. This PC will also have the IP address. And these are the details which uniquely identify these particular machines over the internet. And this firewall can only able to allow or deny the traffic on the basis of source IP, destination IPs, destination port, source port, and your protocol numbers. Okay. Now, a firewall establishes a barrier between a trusted secure internal network and another network, which is internet. Means what it will make? It will make a secure boundary. Inside this boundary, you have your secure network, because you have your employee systems, your servers, and all these employee system and servers, they are configured according to your organization policies, right? You are not allowed to install some unnecessary softwares, right? You have a approved software which is installed on this particular PC, right? Unknown peoples is not able to connect in your LAN network. So this particular part is known as a inside network, or your LAN network, or your secure network, or your trust network. And what it will do, another part of this firewall have a connectivity with the internet, right? In internet, we have a good peoples and we have a bad peoples as well. Like hackers comes under this bad people's category. The intention of these hackers is just to exploit your environment, just to harm your environment, right? And firewall is basically establishing the boundary between trusted and untrusted networks. So that is the reason the interface which connects with the internet, we always put on a outside zone, or either on a WAN zone, or either on a internet zone, or either on a untrust zone. So if I use the term like if my traffic coming from inside and going towards outside, which means the user who is a part of LAN network trying to communicate with the server over the internet. Okay, so these are the terms I will use frequently, and I hope everyone understood like what is inside, what is outside, what is trust, what is untrust. Any questions anyone have on these terms, guys? Because these are the basic terms. If you are not clear with these terms, you will not able to understand the things. Okay, now let's add some more point in the same definition. What is firewall? So guys, as I have mentioned in this particular term called what is firewall, I have mentioned two things. It will control the traffic and it will inspect the traffic. When I'll say the terms called inspect, your inspection happens at your data or your users data or your application layer data. Because because you know, if some one application wants to communicate with the another application, right? According to your TCP IP OSI model, they basically take help of application layer, right? Because at application layer, whatever you will enter, let's suppose you have entered http.facebook.com. That time firewall receives raw data at your application layer. So the inspection done at your raw data means inspection is a part of layer 7. So at your layer 7, inspection needs to be performed. Controlling means we are looking the layer 3 and layer 4 information. Means at layer 3 we have a source IP, destination IP. At layer 4 we have a source port and destination port fields, right? So means if you want to control the traffic, we have to use the information from layer 3 and layer 4. If you want to inspect the data, we have to take the help of your layer 7 content. Okay, and guys, if you remember, We have a generally two type of firewalls. We have a legacy firewalls and we have a next generation firewalls. And the major difference between legacy firewall and next generation firewall, legacy firewall can only able to provide the control, means they can only able to allow or deny the traffic on the basis of layer 3 and layer 4 information. And your next generation firewall, they can control the traffic on the basis of layer 3 and layer 4 information. Also, they can able to inspect the data, means they have a capability to read the data at layer 7. And nowadays, whatever like your vulnerability protection or your antivirus protection, anti-spyware protection, all these features comes under the layer 7, because if some hacker try to add some type of malicious code, then that time that particular code is available at layer 7. Okay, so your next generation firewall provides protection against these type of unmalicious traffic as well by analyzing or by inspecting the layer 7 information. Okay, that's the definition of your firewall. Now we have a couple of companies, guys. Let me write down few name of the firewalls. So we have a list. We have a list of next generation firewall and we have a list of legacy firewalls. Guys, on this particular next generation and legacy, I have one video on YouTube. So I will give you that video as well so you can learn the more detail of these things. Okay, what is legacy, what is next generation? So your next generation firewall, the very first firewall in this next generation list is your Palo Alto. Then second next generation firewall is your Fortinet or FortiGate. Third next generation firewall is Checkpoint. Fourth one is your Cisco FTD, FMC. In this particular legacy list, we have a very first firewall, most popular firewall, which is Cisco ASA, most used firewalls. Then we have a Juniper SRX. Then we have a Sonic Wall. Then we have a Cyber Roam. Like that, we have a huge list: Cisco ASA, Juniper SRX, Sonic Wall, Cyber Roam, right? Then there is a like couple of more firewalls, like Sophos is there. There are a hell lot of legacy firewall list. Okay. So guys, these are the next generation firewall list and this is the legacy firewall list. Major difference between next generation firewall and legacy firewall. Your next generation firewall can process the traffic at layer 3, at layer 4, at layer 7. And your legacy firewall only able to control the traffic on the basis of layer 3 and on the basis of layer 4 information. That's the major difference. Now let's try to understand there's a one technique called stateful inspection. I hope everyone aware about that technology. What is stateful inspection? Anyone have any idea about the stateful inspection, guys? So now let's start the stateful inspection. So a stateful inspection is a technique or is a mechanism which allows a firewall to maintain the state of a connection on a table called state table or a connection table or a session table. Means what used to happen according to your TCP IP model, we have a layer 3 and we have a layer 4, right? At layer 3 we have a source IP, destination IP and layer 3 protocol number. And at layer 4 we have a source port and we have a destination port. So what according to stateful inspection, now let me just explain you. First, guys, what I will do, first we will try to look for the stateless behavior or state. What is the stateless behavior? And after that, we will try to discuss stateful inspection. So let's try to understand the stateless behavior. And your router and your access control list is the best example of stateless behavior. So now let's try to understand how router used to process the packet. So let's suppose we have one PC here, PC1. That PC have IP address 10.1.1.70. Then this PC have a connectivity with one of the router here, router R1. Let's say this is Ethernet 1x2 interface. And here I have server. This is Ethernet 1x1 interface. Let's suppose this server have IP address 10.2.2.101. And let's say this server is hosting TCP service on TCP 22, means it is a SHS server. Or let's go in this way. Let's say this server hosting the service on TCP 80 and it's a web server. Okay. And this particular server have one of the file of 2 GB .mp4 file, and that file this particular PC wants to download from that server. Now let's try to understand the series of activities happened here. So as I have mentioned, let's suppose this particular router, this interface is a part of inside zone, and we have this interface is a part of outside or not outside. Let me just go with the DMZ. This is your DMZ interface. Here you have one IP address. Here also you have one IP address. Then IP address is 10.1.1.250 here, and here you have a 10.2.2.250 IP address on this particular Ethernet 1x1 interface. Very simple setup. Now let's try to understand the things. So guys, just tell me one thing. Let's suppose this PC1 wants to access some services on this particular server. So this PC has opened his browser and he has typed the IP address 10.2.2.101. What is the first thing will happen here? What is the first packet is sent by this PC towards this particular server? The very first packet is TCP SYN. Yes or no? The very first packet is TCP SYN. And if I will write down the content of that packet, in this particular packet, we have a source IP address which is 10.1.1.70. Destination IP address is 10.2.2.101. This is source IP, destination IP. Then we have a source port. So this particular PC will pick the random port number. Let's say it has picked 3050. And we have a destination port which is fixed, right? Which is 80. Now, tell me one thing. Now, guys, this particular request is received by this router. Now, anyone know when this router received the request, what this router will do? Anyone have any idea about it? We have received a TCP SYN packet on the router. What this router used to do? Check the route table, check the ACLs, right? Check the SEP table, check the net rules, all these things. So let me tell you guys, when this router used to receive a packet, let me tell you one thing, what it used to do. It used to perform 27 checks. There are 27 checks available in this particular router. Means I will not write all the checks, I will just write couple of them. When this TCP is received on this router, so what it will do, it will put this particular packet into the ingress stage processing. It will put this packet into ingress stage processing. It will start parsing your packet, right? Then it will basically check your routing table. It will check your net rules or net table or net policy, or I can say net rules. It will check your access control list, ACLs. If you have configured the policy based routing, it will check the policy based routing, right? If you have configured BPN and other things, then it will check all these BPN related stuff and all, right? There is a hell lot of things. It will check the SEP table. I will just put ETC. And after at the end, what it will do? It will basically forward this packet through the forwarding stage. This is how the traffic is processed by this router generally. So now this router has processed the packet. When he did the route lookup, he has find out 10.2.2.101 available behind Ethernet 1x1 interface. So it will basically exit out this traffic through Ethernet 1x1 interface. Right? Now this server will send the reply, which is a TCP SYN plus ACK. Now TCP SYN plus ACK is also received by the router. And guys, this particular router will process the TCP SYN plus ACK again against all these 27 checks. And after that, this PC will send the acknowledgement, TCP ACK. And when this TCP ACK received by this particular router, it will again send this TCP ACK packet through all these 27 checks. It will forward this packet toward this server. And after that, once TCP 3-way handshake will complete, now he will send the HTTP GET request. HTTP GET will also go through with all these checks. Then we will receive the HTTP response. Then the series of HTTP GET and HTTP response will be there. So let's suppose this PC, when he was trying to download this 2 GB of file from that server, let's suppose they have done around, they have exchanged around 200 packets in total. Means he has sent 100 requests and we will get the 100 replies. Means total 200 packets we have basically they have exchanged with each other. Now tell me one thing. Let's suppose hypothetically this router needs around 2 seconds for processing TCP SYN, TCP SYN plus ACK, HTTP GET. Means each and every packet is processed by the router in 2 seconds. So to process each and every packet, or to process all these 200 packets, how many seconds of time is needed by this router? 400 seconds? Yes or no? So it will basically take around 400 seconds, right? To process the packets. No. This is the stateless behavior, guys. Means whatever request this router will receive for a same connection. This is a same session, guys, right? This PC is trying to communicate with this server. This is the same flow, right? This is exact similar flow. And we are receiving 100 requests for the same flow, and we are receiving the 100 reply for the same flow. And so guys, here this router is not maintaining any type of table. Means each and every packet needs to go through with all these 27 checks. This is the stateless behavior. This behavior is known as a stateless behavior. Now, let's try to understand the stateful behavior. Let's try to understand the stateful behavior. In stateful behavior, let's suppose now instead of this router, we have a firewall. Now let's suppose we have here firewall. And guys, I am specifically going with the Palo Alto firewall. Okay, let's suppose we have a Palo Alto firewall now. And guys, if you don't know, let me write down couple of things here. Palo Alto firewall packet processing stages. Okay, I will discuss these stages later as well in detail. But here just you have to know the names. So Palo Alto process the packets in 7 stages. Okay, the very first stage is known as ingress stage. The second stage is known as flow lookup. Third stage is known as slow path or session setup stage. Flow lookup, or you can put here session lookup as well. Then we have a fourth stage, which is fast path. Then fifth one is your app ID. Sixth one is your content ID. And seventh stage is known as forwarding stage. And guys, in this slow path, your major checks like your routing table lookup, your net, your security policies, your DOS policies, your user ID, user-based policies, all these are part of slow path. Okay, now let's try to understand the same thing with regards to the firewall perspective. So guys, now this PC is trying to send a packet over this server, which is TCP SYN. Now when this firewall receive a TCP SYN, and guys, let me tell you one more thing before going into that one. Guys, TCP SYN, SYN plus ACK and ACK. These three packets will not have, they don't have any type of layer 7 data. Means layer 7 data is not available in your SYN plus ACK and ACK packet, just remember. Because TCP SYN plus ACK and ACK, they don't have any type of layer 7 data. Means at layer 7, we have nothing here. Just remember. Okay. So guys, now. So now what used to happen? Now this TCP SYN request received by the firewall. And now how this firewall is going to do the processing of TCP SYN. So guys, just remember this particular processing you have to remember. TCP SYN processing. How my firewall going to do the packet processing, or how my firewall going to do the TCP SYN packet processing. So TCP SYN packet processing is done in these stages. The very first stage is known as ingress stage. Then the second stage is known as flow lookup. Then we have a third stage, which is known as slow path. Then we have a Fourth one, fast path. Then we have a fifth one, which is forwarding stage. Why this particular packet will not go through with app ID and content ID? Guys, this app engine and content engine comes in a picture when we have a layer 7 data. And in your TCP SYN plus ACK and ACK, they don't have any type of layer 7 data. So these three packets will not go through with the app ID and content ID engine, just remember. So that's how the TCP SYN request is processed by the Palo Alto Firewall. And guys, when your packet received at this particular SYN received at ingress stage, in ingress stage generally it will basically try to extract the source IP, destination IP, source port, destination port, layer 3 protocol details. All this type of extraction happens at your ingress stage. In ingress stage, it will also check the header errors. Like we have a TCP header, we have a IP header, right? All these headers are perfectly formed or not. Is there any type of header parameter which is missing or any header field which is missing, right? That will check all these things. Means it will try to check the ingress processing errors from the packet. Now in flow lookup, this is the most important thing. In stateful inspection, what used to happen, this device called firewall create a create a or it will maintain the state of a session. And how it will maintain the state of a session? It will basically store the session detail or store the flow detail into the flow table or a session table or a connection table. Multiple vendors use multiple names. And what is the information they will store into this particular flow table? They will store the source IP, destination IP, source port, destination port, layer 3 protocol number, and source zone detail. This is the information which they will store. After storing this information, this packet will go towards the slow path, fast path, and forwarding state. Okay. Now, when we receive a reply from that particular server for this flow, now this particular reply will go through with the ingress stage, and when they will perform the flow lookup, that time session information is there into your flow table. And if session detail available into the flow table or session table, they bypass your slow path check. They directly jump the packet into fast path, then forwarding stage. Means this particular technology or mechanism, stateful inspection, will store the session information into the session table, and that information they will use to bypass the slow path for subsequent request and reply packet. This is your subsequent reply and this is your request, right? Whatever request packet and reply packet is received by this firewall, they will bypass the slow path check. And guys, if you have seen here in slow path, they have a major checks, your routing table, which needs time, your net table, your security policy, your access control list, ACLs, your DOS table or DOS policies, your user based policies, right? These are the main policy which really needs time, guys, in the packet processing. Okay. And in your, so guys, let's suppose this firewall will also take around 2 seconds for processing one request or one reply. Your slow path will take around 1 second itself, because in slow path we have a major checks. What? Because in slow path we have a major checks. Okay. Now let me just put some details how SYN plus ACK is processed by the firewall. TCP SYN plus ACK. TCP SYN plus ACK is processed by the firewall. It will send this packet through ingress stage. Then your flow lookup. Then your fast path. Then your forwarding stage. Your third packet, which is TCP ACK, is also processed in similar fashion by the firewall. When we will receive this HTTP GET request, this packet is processed at ingress stage. Then your flow lookup. Then your fast path. Then your app ID. Then your content ID. And after that, the forwarding stage. Because your HTTP GET is the message who has some layer 7 data. So this is the packet will go through with app engine and content engine. Now guys, if you have seen here in stateful inspection, what happening? Due to this technology called stateful inspection, every device is maintaining the session. It is maintaining the session detail. What it is doing, it is basically creating the, it is maintaining the session detail. And on that session, it will store your source IP, destination IP, source port, destination port, layer 3 protocol number, and your source tune. And due to this particular session detail available in the session table, it will basically allow this particular subsequent request and reply packet, and it will bypass the slow path check. And now let's suppose if we need around, we have here 200 packets. Out of 200 packets, if you will see, only there is only first packet who needs 2 seconds, and remaining packets will take around 199 seconds. So if we have a firewall here instead of router, then it can able to complete the whole transaction just in 201 seconds. Now see the difference due to this particular mechanism, how it has improved the inspection behavior of a device. It has completely changed the inspection behavior of your devices. That's the beauty of stateful inspection. And guys, this particular technology, stateful inspection, is introduced in 1993. There is a person, his name is Nirjuk. He was a part of Checkpoint Tech team. He was a tech engineer in Checkpoint. In 1993, this person has developed he has developed this particular technology called stateful inspection. And guys, after 1994 onwards, all the other vendors has implemented this stateful inspection behavior into their firewalls. So guys, this year 1993 is the revolution year for the firewall industry, because it has completely changed the inspection behavior. It has completely changed the inspection behavior of a firewall. And guys, the same person Nirzuk, first he was a part of NetScreen organization, which is known as Juniper nowadays. First, he has started his career with Juniper. From Juniper, he moved to Checkpoint. During his Checkpoint journey, he has invented stateful inspection. And after this, he has left Checkpoint and he has released in 2005 his own firewall, which is known as Palo Alto Networks. So Palo Alto Networks is a firewall who is developed and designed by the person called Nirzuk. And he has introduced this device in 2005 first time. Okay. So guys, I hope you understood the stateful inspection. So now let me tell you what is stateless behavior. A stateless firewall watch the network traffic and restrict or block the packets based on source IP, destination IP, source port, destination port, and layer 3 protocol numbers. A stateless firewall do not maintain the state of the connection on the session. Extended ACLs in your Cisco routers is the example of a stateless firewall. This is the best example of a stateless firewall, guys. In stateful inspection, it checks the layer 3 and layer 4 information within the IP packet and store that information in a separate table referred as a state table or a session table or a connection table. All these are the different names, guys. All traffic flows through the firewall will be compared or inspected against the state table entries. It maintains the state of a connection when packet is traveling for the appliance. A stateful firewall maintains the state of a connection in the state table of the firewall. After adding information in state table, it forwards the packet to the destination. When it receives the reply packet, it matches the packet information to state table. If firewall receive the reply packet, if match packet is accepted, otherwise dropped. Means what it will do, if whatever reply we will get or whatever new request we will get for the same flow, what it used to do, it used to bypass the slow path check. It completely bypass the slow path. Okay. So that's the main definition of your stateful inspection. Guys, TCP states and all I'm not going to discuss now because not needed as of now. So now let's try to understand what is Palo Alto Networks. So guys, as I have mentioned, this Palo Alto Networks firewall is released in 2005 with the person called Nirjuk. And that time, guys, Palo Alto is the first firewall who has supported the app ID based rules. Means you can able to control your traffic on the basis of applications. This is the first firewall who come with this particular feature, app identification. This is the first firewall who come up with the user based policies. Means you can able to do the user identification. And this is the first firewall who has basically provided the content identification during that time within the same box. Because if I will tell you the Cisco portfolio, if you want to protect your traffic, you have to purchase Cisco ASA, like layer 3 and layer 4 protection. If you need a protection for applications, content and all, you have to purchase one more box, which is Cisco IPS, a dedicated solution, a dedicated box, right? But Palo Alto is the first firewall who was offering all these features just within the same box. So that is the biggest reason, guys. Palo Alto has introduced in 2005, just within 3 years of a span. It in 2008, Palo Alto Firewall become the #1 firewall according to the Gartner report. And from 2008 till today, 2023, Palo Alto Firewall is leading the firewall industry and it is the most used firewall. It is the leader in the firewall industry from 2008 till 2023, like till today's date. So you can say Palo Alto is the most used firewalls nowadays. Now, guys, how basically the name of this particular device Nirjuk has put as a Palo Alto. So, guys, Palo Alto is a city in California, and according to that particular city, they have put the name of this particular device as a Palo Alto Networks. Okay. Palo Alto is a USA multinational cyber security company and headquarter of Palo Alto is in California. Palo Alto 5 introduced in 2005 by Israeli American Nirjuk. Nirjuk is a formal engineer into checkpoint and NetScreen, which is your Juniper networks nowadays. And Palo Alto having world-class team nowadays with a strong security and networking experience. Okay. The main component of Palo Alto Networks is your user ID, app ID, content ID. These are the main features of Palo Alto. Okay. Palo Alto do have a tech support by 24/7. And this is like a Gartner report. You can see this is a Gartner Magic Quadrant, and according to that quarter, Palo Alto is still leading the firewall industry. So guys, we have just discussed the what is firewall, stateful inspection, Palo Alto firewall history. Now let's try to understand the Palo Alto firewall product portfolio. Means what type of product is available in you in or offered by the Palo Alto networks. So guys, if you will see here, Palo Alto firewall offers like an enterprise based security appliance and cloud based security appliance and the logging solution as well. Means we can able to secure your data centers traffic, internet perimeter, branch and mobile branches and your mobile networks, 5G and IoT and endpoint as well. And that particular bin is known as strata. And this particular bin, we have a couple of devices which includes your machine learning powered next generation firewalls, which are your Palo Alto devices, Palo Alto network firewalls. We have a Panorama. Panorama is a manager for managing your large scale firewalls. We have a wildfire solution. We have a global protect, and we have a Prisma access. Prisma access is the cloud based SASE solutions we will use for securing the access, securing the SaaS traffic, securing the public cloud traffic. Palo Alto do have a data lake solution, which basically used for detection and response and automation and orchestration, network traffic and behavior analysis and threat intelligence. Means this data lake works on the logs. Whatever logs we will be having, we try to send these logs to data lake. So these are the some solutions offered by the Palo Alto firewall. So the foundation of Palo Alto network security. Panorama is for the management purpose. Then Wildfire provides us the zero-day malware protection. Global Protect is for the remote access VPN solution, and Prisma Access provide the SD-WAN based secure access to the cloud from remote sites and for mobile users globally and without compromising the user's experience. Securing the cloud, we can go with the Prisma Cloud and Prisma SaaS solutions. Prisma Cloud provides continuous security monitoring, compliance validation, and cloud storage security capability across multi-cloud environment. Prisma SaaS brings data protection, governance, compliance together to safely enable SaaS application adoption in the environment. Then these are the, if you want to secure the future, which means how we can secure our logs for future use. They offers the Cortex Data Lake solution. Cortex Data Lake provides cloud-based centralized log storage and aggregation of your enterprise security data. Cortex XDR prevents malware, block exploit, and analyze suspicious patterns through the behavior threat protection. Cortex XOR enables security teams to accelerate response across people, process, and technology. So these are the some solution or some product portfolio offered by the Palo Alto networks. Now the main thing, let's try to understand the Palo Alto firewall operating system. What is PAN-OS? So guys, the operating system which is available in your Palo Alto devices is known as PAN-OS. PAN-OS is the operating system. One minute, let me just increase this here. PanOS is a Palo Alto Firewall operating system. Now, so guys, do you know what is Linux? Anyone have any idea about the Linux operating systems? Hello? I hope everyone know the Linux operating system, right? So guys, nowadays, like let me tell you, Linux generally is the open source operating systems, right? And if you want to make any type of modification on the Linux operating system, you can able to do that because they are open source, right? So what Palo Alto has done, there was a one Linux flavor which is known as BSD Linux. There was a one Linux flavor called BSD Linux. So what Palo Alto did, they have basically taken this BSD Linux operating system. On this operating system, they done some customization. Means they have removed the unnecessary code, they have removed the unnecessary packages from the Linux operating system. Means they did customization according to their requirement. After doing the customization, what they have done, they have added the pen application. They have added the pen application. And once they've added the pen application, what they got the Pan OS. So Pan OS is a combination of customized version of BSD Linux plus pen application. Now guys, let's suppose in your Linux environment, let's suppose you want to access this Linux by using SHS. Then what is the process is running in your Linux environment? Let's suppose you want to run some web services on the Linux environment. Then there are the processes, right? There are the daemons. We have the daemons. Let's suppose for SHS, we have a daemon called SSHD. For web services, we have a daemon called HTTPD. HTTPD. For DNS, we have a DNSD. Like for every service, we have a daemons in the Linux. So guys, the kernel of your Palo Alto operating system is based on the Linux, or kernel of your Palo Alto operating system is the Linux environment. Kernel of Palo Alto operating system is the Linux environment. And guys, this particular Linux kernel, or the kernel of Palo Alto operating system, is the Linux environment, which means in your PAN-OS we have a daemons for every services. Let's suppose you are taking the SHS access of the Palo Alto, then there is a one SHS process or SSHD daemon is running. Let's suppose your firewall used to, you have configured the IPsec VPN, right? That time there is a one key manager daemon is running. There is a crypto daemon is running. There is a IKE MGR daemon is running. Means we have a daemons in your Palo Alto operating system. So PanOS is a customized version of your BSD Linux and Pan application, just remember. And the latest Palo Alto operating system is your PanOS. PanOS 11 series. And let me just tell you the detail. I have one document on my system. Where is that document I have put? Yeah, this is the one. So guys, if you want to check what is the latest operating system, you have to go to into this, you have to basically search over the internet like PanOS stable version. You will redirect to this link, and in this link you will see PanOS for firewalls, and there is a P means this is the most preferred version. So guys, the latest version of Palo Alto is PanOS 11. This series is known as Nova series, and the most stable version in 11 series is 11.0.2 -H1. This is the most stable version, and this version is basically stable for this particular firewall series. Still this version has this particular open vulnerabilities. Then we have a 10.2 series, which is known as Nebula series. And you can see these are the most stable version into that series is 10.2.5. And guys, in my lab, I am going to use 10.2.5 version for doing most of my labs because this is the most stable version. This version is still have some issues, this 11. So I'm not using 11. I will use 10.2.4 and 10.2.4 S2. Okay. Then we have a 10.1 series, 10.0 series, then we have a 9.1 series. So here you will get the entire series. Apart from that, you will get the panorama stable version details, right? Then you will get the global protect stable version detail. Right now, stable version is 6.1.2. User ID stable version details. So all these particular details you will get into that particular website. I will provide you that link as well. That's not a big deal. So I hope guys everyone understood the operating system of Palo Alto. Palo Alto operating system is known as PanOS, and PanOS is the customized version of BSD Linux and Pan applications. And guys, if you want to see, let me just log into this firewall. Let me just show you something. So this is my firewall 2, I hope, and don't worry guys, because your lab setup and other things we will do in next lecture. That time you will basically able to get all the details. Okay. How to access the firewall, everything I'm going to cover. So if you run this command, so system software status, you can see all these particular, they are the daemons which are running. See, we have a pen task daemon who will basically do the packet processing. We have a author daemon. Whenever you will log in into this firewall, this is the daemon who will validate your login credential. Right? Then we have communication, content D, crypto D. This particular daemon is responsible for your cryptography related task. Dagger, DHA, DSCP, right? There is a hell lot of daemons are there. SSHD, SSLMGR, right? All these are the daemons running because Palo Alto is the Linux environment in backend. Even though guys in your Windows also these processes are used to run. If you will go into the task manager of your window, these particular processes are running. Sir, and go to into services. These are the services which are running, right? It's the same thing, guys. Okay, just remember. Now, guys, let's try to understand the Palo Alto hardware series or what type of appliance offered by the Palo Alto networks. So, guys, Palo Alto offered physical appliance, virtual appliance, and your CN series appliance. So, we have a majorly three type of series: physical appliance, virtual appliance, and CN series appliance. Okay. Now, in guys, physical appliance series, let me write down all these series here. 1 minute, let me just see where I can get some space. Okay. So guys, let me just start the what are the hardware appliance offered by the Palo Alto networks. So the very first series which is offered by the Palo Alto firewall is known as a Palo Alto 200 series. Recently, Palo Alto also introduced one more series which is known as a Palo Alto 400 series. Palo Alto also offered one more series which is known as PA 800 series. Then Palo Alto also have one more series which is recently introduced, which is Palo Alto 1400 series, PA 1400 series. Then we have a Palo Alto. We had around 200 series as well. 6.1. We have a Palo Alto 300 series box as well. Then we had a Palo Alto 4000 series as well. We had a Palo Alto 5000 series. We have right now Palo Alto 5200 series. Recently, they have introduced one more series, Palo Alto 5400 series box, right? And they do have a Palo Alto 7000 series. So guys, these are the hardware series offered by the Palo Alto network devices. In Palo Alto 200 series, guys, majorly we have a two type of box, 220 and 220R. Palo Alto 220 is just for the small sized organization where you have a user count like 1 to 100 or 1 to 50. You have a very less traffic, right? So Palo Alto 200 series and Palo Alto 400 series or for the small business units. These two series is used by the small business units. Palo Alto 220R series is for the places where we have a humidity like Chennai and all, where we have a humid area. Then we have Palo Alto 400 series. And after that, they have introduced Palo Alto 800 series where we have a 820, 850, and I hope 860. These are the three box available in PA 800 series. Recently, they have introduced Palo Alto 1400 series. So this is the new generation firewall like Palo Alto 400, 1400. All these comes under the new generation series nowadays. Okay. Now guys, your 800 series, 1400 series, 2000, 3000 and 4000. This particular series is for the medium sized organization. Medium sized organization. According to your users, according to the throughput in your environment, you can able to decide which model you have to go. Guys, this Palo Alto 200 series, 300 series and 4000 series is out of sale. They are not available. I forget to mention that there is a new series which is Palo Alto 3200 and we have a Palo Alto 3400 series box as well. So 200, 200, sorry, 2000, 3000, 4000 is not available nowadays, but you will see PA 3200 and PA 3400 series available still. 5000 series is still you will see into some data centers, but most of the companies they are using Palo Alto 5200 and 5400 and the 7000 series. They are the data center level devices where we have a high throughput, where we have a huge traffic. So these are the couple of hardware appliance guys offered by the Palo Alto Firewall. And if you want to get the list of each and every appliance, what you need to do, you have to basically, where is I have, let me go into this particular link. So guys, here you will get all the hardware appliance which is offered by the Palo Alto Firewall. And you can see we have a in 5400C, we have a PA 5410, 5420, 5430, right? Then we have 5440. And even though you can able to check the details, you can able to see what is the app ID throughput, what is the threat prevention throughput, what is the connection per second, maximum section supported like which is IPv4, IPv6 sessions, then performance with app ID, firewall throughput, with threat prevention, VPN and all these things, right? So you can able to check entire details into the data sheet of this particular box. So we have a 5400 series, then we have a 3400 series, right? Then we have a 7000 series, like your this series 54 and 34. This series is comes under the generation, new generation devices. Okay. Then we have Palo Alto 7000 series. These series you will see in the data centers, right? We have a 5450, then 50 to 80, 50 to 60, 50 to 50 and 50 to 20, then 3200 series. So you can able to get the entire details here. Then we have a PA 1420, 1410 as well, right? Then 850, 820, then 460, 450 series, right? So then 220, 220R and 220, right? All these series are available, or these are the hardware appliance offered by the Palo Alto networks. Just remember. Apart from this, basically, so as I have mentioned, Palo Alto has categorized their devices according to the use, right? For small business units, for medium size organization, and for data centers. So a small business unit generally have PA220, then 400 series, 1400 series, and 800 series. Sorry, this 800 series, 1400 series, and your 3200 series for medium size organization, and your 52 or 72 or 54, all these series for the data center level devices. So these are the couple of hardware appliances offered by the Palo Alto Firewall. Apart from these hardware appliance, Palo Alto do offers the virtual appliance as well. VM series, and these particular VM series you can able to deploy in your VMware hypervisor, in your EXI hypervisor, in your AWS cloud, in your Azure cloud, in Oracle, GCP, right? All these particular cloud environments, if you want to implement the Palo Alto, then you have to go with the VM series devices. Like we have a VM 700, VM 500, 300, 100, and 200 series, and VM50 light version of it, right? They have some defined memory, SSD, and all these things. So these are the some VM appliances offered by the Palo Alto. The entire list is available into this link. VM series with 2 CPU and 4.5 GB of RAM, it will have around 3 GB of throughput, right? 1.5 GB of throughput with threat prevention license. It will support around 3,000 connection per second. Maximum second is 50,000. So you will get all the details here. We have a like this particular VM series device, the last one, right? It has a huge throughput. So if you have a huge throughput and you want to deploy that, see, you can deploy it like VM with 22 virtual CPU and 56 GB of RAM in your public cloud environment like AWS, GCP, Azure, and Oracle, right? And they will provide you the 20 GBps throughput, 14 GBps throughput with threat prevention and all, right? So all these details you can able to get here, guys. Now, apart from this series, there is a one more new generation firewall series offered by the Palo Alto, which is known as CN series devices. These are the cloud native series firewalls. And guys, this is a future. Cloud native series firewalls is the future. Because in future you will see all the CN series type of devices is used by the peoples a lot in the cloud environments or in the virtual environments and all, because these device you can able to deploy, you can able to manage, you can able to configure with the help of Kubernetes clusters. These are like a Docker images. Okay, so these particular series is also offered by the Palo Alto Firewall, like a container native series firewall. So CN series provides visibility and security to containerized application workloads, natively integrates into Kubernetes clusters, provide layer 7 visibility, application level segmentation, DNS security, and advanced threat protection. Protects traffic across trusted zones in the public cloud or the data center environment. So these are the some cloud-based series, guys, or the CN series devices available. There is a one, this is not a series, guys. You can able to configure the virtual systems as well on your firewall, where we can basically divide the physical firewall into multiple virtual or multiple logical units, which is known as virtual systems. In your Cisco ASA, you have heard the name of context, or in your router, we have a VRF type of concept, right? So it is VSS is the similar thing. Okay. Now, guys, let's try to understand where. very important topic, which is known as SP3 architecture of your firewall. Just guys, give me 1 second. Okay, let me have water. Okay, guys. So now let's try to understand what is SP3. And guys, believe me, let me tell you one thing. Let's suppose if you will go for any type of interview, even it is for L1 engineers or L2 engineers or L3 engineers or for tech engineers, what is the first question they will ask, which is, what is SP3 architecture? Can you explain the SP3 architecture? Right? This is the first question asked by the interviewer. So first of all, you have to tell SP3 stand for single pass software and parallel processing hardware. This is the full form of SP3. So SP3 stand for single pass software and parallel processing hardware. And guys, due to this particular architecture, Palo Alto Firewall throughput is very high. This is the also one of the biggest reason Palo Alto Firewall basically leading the firewall industry. Okay, so now let's try to understand SP3. So guys, if you know Palo Alto devices single pass architecture, so Palo Alto has a two components. Palo Alto devices has two components. The first component is known as a control plane and the second component is known as a data plane. What is the first component? First component is the control plane and second component is the data plane. This control plane is also known as management plane, MP. And this data plane is known as DP. This is I'm discussing the hardware level segregation, how Palo Alto appliance is segregated. They have a hardware level segregation. They have a management plane, dedicated management plane, and they have a dedicated data plane. And this data plane is further divided into three another planes. You can see these three: networking, security, and content inspection. These are the three another planes in your, or these are the three another planes we are having in your Palo Alto network devices. Okay, now let me just guys draw one diagram. What are the functionality of all these? Because see, I will share you this PDF, that's not a problem. Okay, now let's try to understand the exact architecture of Palo Alto Firewall, and after that we will see other things. Okay, so guys, let's try to draw one diagram. Let's suppose we have a PC here, PC1 10.1.1.70. We have a firewall, and this firewall have a connectivity with the internet, and here we have a server running on TCP 443.150.1.7.100. Simple example. Now, what used to happen, guys? Every firewall, they have a interfaces, right? So let's suppose our firewall will also have couple of interfaces here. And guys, I'm discussing, this is the very advanced level information. Okay, this is the very advanced level information. And if you know this information, then only you can able to understand the architecture, like what is data plane, management plane, and all. So in this firewall, we have a data ports starting with Ethernet 1x1, 1x2, 1x3, 1x4, 1x5, 1x6, 1x7, Then we have Ethernet 1/8. After that, we have a 4 ports here. Ethernet 1/9, Ethernet 1/10, Ethernet 1/11, and Ethernet 1/12. These are the simple ports we are having here. Let's suppose. Okay. Now, this particular port, they are a copper port. And let's suppose starting with Ethernet 9 till 12, these are the fiber ports, SFP plus SFP ports of fiber ports. Okay. So guys, this particular board is known as a interface board or interface module. This particular thing is known as interface module or interface board. Okay. And after that, this particular interface board has a connectivity with one of the chip called Marvel chip. We have a Marvel chip here, and we have a one more chip is known as a Petra chip. All your copper ports, they have a direct connectivity with this particular Marvel chip, like this. Okay. Or for this simplicity, let me just do that one thing. Let me just draw. They have a connectivity like this. All the interfaces. And your fiber interface, they have a connectivity with the Petra chip. This particular thing, Marvel chip, a Petra chip, is also known as a switch fabric. What is this switch fabric, guys? We need some type of hardware device, right? Who can convert the who will convert your 0 and 1 information, right? This particular 0 and 1 into your layer 3, into your layer 4, into your layer 7, layer 2 packets, right? We need some type of hardware appliance who can read this particular binary forms, and he can able to convert them in a proper data. So this particular task is done by the switch fabric. Okay. And after that, this Marvel chip and Petra chip, it has a direct connectivity with one more chip inside your Palo Alto firewall. And this chip is known as a Liger chip. And low-end boxes and high-end boxes have a Tiger chip. This is the FPGA, Field Programmable Gateway Array. And this particular component is known as a network processor, NP, network processor. And this particular chip has a connectivity direct with this particular network processor via these particular links. These are the high speed fiber links, is known as a joy links. These are the high speed fiber links, is known as a joy links. And after this, this network processor has a connectivity with one more chip. One more hardware component is known as a Octeon chip. This Octeon chip is also known as a DP-CPU, data plane CPU. An Octeon chip and Liger chip will also have a connectivity via joy links. This is known as the data plane CPU. And after that, this particular Octeon chip will have a connectivity with one more chip called Jaguar chip. This Jaguar chip is known as a signature match processor. Signature match processor. And this is also a FPGA. This is your security processor. This is your networking processor, NP. Now this particular Jaguar chip is only responsible for doing these two tasks, app identification and your content identification. Your app ID and your content ID related task is done by the Jaguar chip or Jaguar engine. Now guys, if you have noticed, just notice this diagram now. I'm just let me just open the same thing here. So I will just use this as well. So I will not able to switch more. Okay, so guys, now just notice here, did you have seen? We have a dedicated management plane and we have a data plane. And this particular data plane has dedicated networking processor, security processor, and content processor. So guys, this networking processor, this one, this is NP, this is your Octeon chip, and this is your Jaguar chip. Means what Palo Alto has done, Palo Alto has divided its hardware into two parts, into two planes, management plane and data plane. And after that, this data plane is further divided into three another planes. And each and every component, they have a dedicated task to do. Means your network processor has a dedicated task to perform. Your data plane CPU, your Octeon chip has a dedicated task to do, and your Jaguar chip has a dedicated task to do. Means now they have a dedicated, these are the dedicated chip, I can say, or ICs, internal component of your Palo Alto device who can perform different tasks in the user's data or in the packets, basically. Okay, this is the data plane. This is how the data plane of Palo Alto is divided into three planes. These are these particular three planes, guys. Now let's try to understand the first. To understand this SP3 architecture, we will first understand the parallel processing hardware. What do you mean by the parallel processing hardware? So simply you have to tell Palo Alto architecture is divided into two parts at the hardware level. We have a management plane and we have a data plane. Now that data plane is further divided into three another planes: network processor, security processor, and content engine. Okay, guys, this particular data plane, or sorry, this particular management plane has a dedicated task to do. Now let's try to understand these particular tasks. Let's try to understand these particular tasks. So guys, your management plane, if you will see, which is also known as control plane, this management plane is only responsible for your configuration management. Means whenever you will make any kind of config changes, this is the responsibility of management plane. When you will take the access of this device via SHS or via web UI, means you are basically communicating, or you are establishing the communication with the management plane. So management plane is responsible for your config management, logging management, and the reporting. Means your config management, logging, and reporting, these are the tasks of the management plane. And guys, this particular management plane has a dedicated CPU. It has a dedicated Intel CPU. It has a dedicated RAM. Means it has a dedicated RAM, and it also has a dedicated SSD. Apart from SSD, your management plane of your management port, which is M0x0, is also a part of your management plane, and the console port is also a part of your management plane. So means we have a dedicated management plane, and that particular management plane has a dedicated task to perform. It will not mix the task which is performed by the data plane. Means your management plane is only responsible for the management of your device. Guys, let's suppose there is a one user who is trying to communicate with one of the server over the internet or over the DMZ, and let's say that traffic received by the firewall. Now, which plane will process this traffic? Your management plane or your data plane? Which one? Simple question, guys. Which plane will process this particular packet? Because your users are connected with these particular interfaces, where your users is connected behind these interfaces, this interface board, and whatever traffic is sent by these users, it is processed by the data plane. Just remember, management plane has nothing to do with that particular data. Just remember, so your users traffic is always processed by the data plane. Just remember. Okay, now, and after that, guys, Palo Alto has a data plane, and that data plane is further divided into three another planes. We have a network processor, where we have a, let's suppose we are using here 3260 series of box. Then let's suppose this network processor has a Tiger chip, that is the dedicated hardware chip which is designed for Palo Alto network device by Intel. Intel used to divide these particular chip. Okay, chip is designed by the Palo Alto, but that chip is dedicatedly designed for Palo Alto network devices for doing the network processing related task. Means your network processing engine will perform the route lookup, quality of service, net related task, MAC lookup, flow control related task. Okay, means network processing component comes under network processor. And after that, we have a security processor. Security processor is responsible doing your security policy match, your user ID related task, your URL match, and app ID is not, like there is a some small part of app ID is done by the security processor, and that part I will discuss in your actual sessions, in your packet flow classes. Don't worry. Okay. So means because it will maintain the app ID cache only. Just remember, user identification, URL match is not done by this particular process. I'm not sure how they have put this detail here. Then policy match, SSL and IPsec, and decompression, means these are the tasks done by the security processor. Then we have signature match processor, who is responsible for your app ID and your content ID related task, means or your exploit, viruses, spyware, command and control, all these things done by the signature match processor component of your Palo Alto firewall. Okay, now let's see this particular diagram here. So guys, as I have mentioned, the management plane of firewall is responsible for your config management, logging and reporting. It has a dedicated RAM, dedicated CPU, dedicated SSD, dedicated management port, and dedicated HA port. Means your management plane has a dedicated resources to do his task. It is not sharing any type of resources of the data plane or with the data plane. No. And guys, your data plane is also further divided into three another plane: signature match, security processor, and network processor. And guys, each and every component has a dedicated CPU and dedicated RAM to perform their dedicated task. So guys, they are also not sharing any of the resources with each other. They can able to work independently. What they can able to perform their task independently in a parallel way. Maybe what, let's suppose we have received three packets, 1, 2, and 3. Maybe packet number 1 is processing is happening at the networking processing end, maybe second packet is processed here, and maybe third process packet is processing here. All these three engines doing the processing at the same time in a parallel way. That is the parallel processing hardware. That is your parallel processing hardware, guys. That is known as your parallel processing hardware, because they have a dedicated RAM, dedicated CPU to perform dedicated tasks on the on the packet. They are not using the shared environment. They are not sharing their RAM and CPU with each other, because to perform the task, they need some hardware level resources like RAM, CPU, and all. So that is known as parallel processing hardware of your Palo Alto network device, guys. Because of this type of architecture, what is the benefit you will get? Let's suppose, let's suppose somebody has launched the DDoS attack in your data plane. And guys, now tell me, let's suppose DDoS attack is happen in your data plane. Is your management plane impact? Let's suppose somebody has launched the TCP SYN flood attack in your data plane. Your management plane is safe. Guys, are you able to log in into the device or not in case of DDoS attack on your data plane? We can able to log in into, because for the logging purpose we are using the management plane, right? And management plane has a dedicated resources, right? He's not sharing these resources here. If they are using this shared resource, if they, let's say they are sharing the resources, what will happen? Maybe this DDoS attack consume all the resources, and that time maybe you will not able to log in. So because this hardware level segregation make your firewall unique. What it makes your firewall unique? For the packet processing, each and every component has a dedicated resources. And one more benefit you will get, let's suppose there is some problem in your data plane. Guys, tell me one thing, let's suppose there is some problem in your, in the data plane. Let's say one of the interface is not coming up properly. What is the solution? And other vendor devices, what is the best solution? What you will do? You will reboot the firewall, simple, right? But in your Palo Alto firewall, you will get that type of flexibility. You don't need to restart your entire box. You can just restart your data plane. You can just restart your data plane. You don't need to reboot the entire box. Let's suppose there is some issue in the management plane. You can restart the dedicated daemon or dedicated process into the management plane rather than restarting the entire box. So that type of benefit you will get with the parallel processing hardware of your Palo Alto network device. Now, one more diagram I am having. Guys, now let's try to understand this particular diagram. I hope this diagram is visible to everyone. This is the diagram of your Palo Alto 500 series box. Now in this diagram, if you will see, we have a switch fabric where we have a Petra chip. We have a switch fabric where we have a Petra chip. Then we have a security processor. Sorry, we have a switch fabric where we have a Petra chip. Then we have a network processor where we have a Tiger chip. And this particular Tiger chip is responsible for flow control, route lookup, ARP lookup, MAC lookup, and net related tasks. And here you can see we have a security processor where we have a Octeon chip. We have a security processor where we have a Octeon chip, and you can see here. Here we have a 3 Octeon chips. Means this device has a 3 data plane CPU, DP0, DP1, and DP2. We have here 3 data plane CPU. Means now guys, your actual parallel processing applied in the high-end boxes. in your 5200 series, 5000 series, 7000 series, because these particular series has this type of architecture. They have a multiple chip here. And guys, now this particular chip will do the task. This will do the task. This will do the task. Let's suppose we have received lots of packet. Let's say we have received packet number 1, 2, 3. Maybe packet number 1 processing is happening here. Packet number 2 is processed by this chip. Packet number 3 processing is happening here. Means all these 3 packets is getting processed in parallel way. This is the parallel processing architecture of your Palo Alto device. And here we have a 2 signature match processor. Means here we have a 2 Jaguar chip. And Jaguar chip is responsible for app ID and content ID related task. Okay. So this is the parallel processing hardware architecture of your Palo Alto firewall. Now let's come back here. Now guys, let me add a couple of more points here. In this particular Jaguar chip, it is responsible for doing the app ID and content ID related tasks. So guys, inside your Palo Alto firewall, there are the algorithm. First algorithm is known as DFA and second algorithm is known as AHO. These, and nowadays DFA is basically also replaced by with the algorithm called pscan. Now guys, these two algorithm is responsible for doing your app ID and content ID related task. This is the program which is running in on top of your Jaguar chip for doing this particular task. Okay. And guys, apart from this, if you have seen here, we have a dedicated SSL chip, dedicated IPsec chip, and we have a dedicated decompression chip. So your SSL related task done by the SSL chip, your IPsec related task done by the IPsec chip, and decompression related task done by the decompression chip. And all these particular component is a part of your data plane CPU. Means we have a dedicated component as well for doing the dedicated tasks. These SSL, IPsec, and decompression, they will perform some complex task which really needs the high CPU utilization. And because of these dedicated components, our Palo Alto firewall throughput is very, very high. Like Palo Alto claims, it has a 3 times high throughput in comparison to the other vendor devices. And one more thing, if you will see here, we have a dedicated management plane which has a dedicated multi-core CPU, dedicated dual RAM and dual SSD as well in some high-end boxes. And guys, nowadays, see, this is the 5000 series box. If I will talk about the 5200 series box, here you have a 48 core of CPU, 48 core of CPU, 48 core of CPU. Means this chip can able to do 48 tasks at the same time. This can able to chip able to do 48 tasks at the same time, and this can also able to do the 48 tasks at the same time. Okay. Now, so I hope guys this particular architecture is clear. The hardware appliance. Now let me tell you one more thing. Let me tell you one more thing, guys. Now very interesting thing. Let's take example of Palo Alto 800 series box. In Palo Alto 800 series box, we don't have Marble chip. We don't have Petra chip. We don't have Liger and Tiger chip. We don't have Jaguar chip. We just have a single chip, which is Octeon chip. So just remember, guys, each and every model of Palo Alto firewall is not having this type of hardware level segregation. So your actual SP3 is applied in the high-end boxes. But in the low-end boxes like Palo Alto 800 series or VM series, they just have one chip. But what they have done, that on that chip they have basically done the segregation at the software level. Your network processor, your data plane CPU, your signature match processor, they have done all these type of segregation at the software level as well. At the software level as well, we have this type of segregation. Okay. And guys, now one more thing, let me explain you here. As we have, as I have basically mentioned, Palo Alto Firewall packet processing stages, right? We have a very first stage, which is known as a ingress stage. Then we have a flow lookup. Then we have a slow path. Then we have a fast path. Then we have a app ID. Then we have a content ID. Then we have a forwarding stage, right? These are the Palo Alto Firewall packet processing stage, forwarding stage. Now, guys, let me tell you one thing. Now, this network processor is known as a session offloader. This network processor is a session offloader. Okay. And as I have mentioned, your Octeon chip is a data plane CPU. So means your Octeon chip is responsible for your ingress stage processing, your flow lookup, your slow path, your fast path, your your forwarding stage, and your Jaguar chip is responsible for your app ID and content ID related task. Now you can ask, what is the use of this particular signature match? Now what is the use of this network processor or session offloader? What is the use of that particular processor? Why we have this component in your box? So as the name suggests, session offloader means this particular network processor is only going to process the sessions which is offloaded by the data plane CPU, because main component of your Palo Alto is the DP CPU. And if DP CPU has instructed this Liger and Tiger chip or this network processor, this is the session. Now this session you have to handle means you have to perform the ingress stage, flow lookup, fast path, and content ID and forwarding stage. Means ingress lookup, ingress stage, flow lookup, fast path, and forwarding stage related tasks. These particular 4 tasks is done by the network processor. I think I have mentioned here wrong. This is 5th number, guys. This is 6th number and this is 7 number. Okay. We just have a 7 stages. Okay. Now, so guys, what do you mean by the session offloader? Guys, tell me one thing. Let's suppose my firewall is receiving the encrypted traffic. Let's suppose in my firewall I am receiving the encrypted traffic. And tell me one thing. Can guys firewall able to see the content of encrypted traffic if we have not configured the decryption? Without decrypting, can my firewall able to understand the information? Can my firewall able to read the layer 7 content from the packet which we have received in the encrypted way? Means if we have received the encrypted packet and if firewall is not doing the SSL decryption, or if my firewall is not performing the decryption, can my firewall able to read any layer 7 content? No. It is not able to read. Just remember. So guys, let's suppose I have received a packet, and let's say this packet I have forwarded to data plane CPU, and let's say the same packet I have forwarded to Jaguar chip. Now tell me, this Jaguar chip is receiving the encrypted data. Means data is encrypted, which we have received into this Jaguar chip. Is this Jaguar chip can able to do anything? Can it be able to perform the threat inspection, malware inspection on that encrypted data? No, it cannot able to read anything. So guys, there is any, it is making any type of sense to send the encrypted data to Jaguar chip? No. If we will send the encrypted data to Jaguar chip will not able to do anything, which means it is useless. It is useless. We are forwarding the data to Jaguar chip. So what used to happen when Jaguar chip received the encrypted data, that time what it used to do, because it cannot able to perform anything, so it will send one message to Octeon chip. It will just send layer 7 inspection complete. This message it will send, and that particular flag, this Octeon chip add with this particular session ID. And now Octeon chip no, or data plane no, I don't need to send this particular packet to Jaguar chip. So what this particular chip will do to offload the load from this chip, what it will basically ask the network processor, or it will offload that particular session towards the Liger or Tiger chip, towards this session offloader or network processor, and it will instruct this particular traffic you can process. Now whenever request is coming or any reply is coming for this packet come till this particular network processor. This network processor will perform the ingress, flow lookup, fast path, and forwarding stage. Means it can able to understand the layer 3 and layer 4 information from the packet. It can able to perform the routing, net, ARP, MAC, all these things, and can forward this packet from here. So that is the main use of your network processor or your Liger or Tiger chip inside the Palo Alto. I hope you understood the use of this Liger and Tiger chip. Otherwise, guys, this data plane CPU, which is Octeon chip, is responsible for your ingress packet processing, flow lookup, slow path, fast path, and forwarding stage. Your content ID and app ID related tasks done by the Jaguar chip. Okay, so this is the architecture of your Palo Alto firewall, guys. Now, guys, we have completed the parallel processing hardware, and I hope you have understood how my Palo Alto 5 used to the packet processing, how each and every content do the things, right? You can see here as well, like your signature match processor is responsible for IPS related checks like your antivirus, anti-spyware, vulnerability protection, your malware related tasks, your URL filtering related tasks done by the signature match processor, your application identification done by the signature match processor. Then your security processor, it is responsible for your session lookup, SSL, IPsec, decompression related tasks, your net related tasks, your DOS policy, your zone protection, all these tasks done by the security processor, which is Octeon chip. And your network processor is responsible for your flow control, route lookup, ARP lookup, MAC lookup, QoS, and net. But it will only process the packet which is offloaded by the Octeon chip to the network processor. Otherwise, this flow lookup, route, ARP, MAC lookup, QoS, and net task is also performed by the this Octeon chip or security processor. And initially, this is the processor who will perform all these tasks. Okay. So this is the parallel processing hardware architecture of your Palo Alto firewall. Now let's try to understand the single pass software, because your SP3, this term called SP3 is a combination of two things, right? This SP3 is a combination of two things: single pass software and parallel processing hardware. Okay, I have completed the parallel processing hardware. Now let me tell you what is single pass software. So guys, this single pass software concept inside your Palo Alto firewall is applied at your content engine. When your packet is going through the content ID or going through the content inspection, means your single pass software thing is applied at the Jaguar chip level or at the signature match processor. Signature match processor. Now what used to happen, guys, if you remember, in content ID, this engine is responsible for your antivirus protection, right? This engine is responsible for anti-spyware protection. This engine is responsible for the vulnerability protection. This engine is responsible for your URL filtering. This is the engine who is responsible for your data protection. This engine is responsible for the file protection. This engine is also responsible for the wildfire feature, like for the malware protection. Right? Everyone knows this content engine perform all these tasks. Now, what used to happen basically? How they used to basically perform this antivirus, anti-spyware, vulnerability, URL, data protection, file protection, and wildfire. How they are providing this type of protection. So for each and every module, what they have a signature database. What they have a signature database. Each and every module has a signature database. And Palo Alto Firewall match that each and every packet through that particular database for the protection, like for the viruses, spywares, malwares, exploits, and all. What it will basically match this particular thing against all this particular database. This is the signature database available for everything, for all these features. Now, guys, tell me one thing. Tell me one thing. I have this particular these database. So what used to happen when the packet is received by the Jaguar chip? So what this Jaguar chip used to do, it used to basically store that particular packet into the memory locations. What it used to do, it used to store that particular layer 7 content into these memory locations in the RAM, because in Jaguar chip you have seen we have a 3-4 RAMs, right? In this memory location it will use to store the database. And in this content engine where it is running these small programs of all these particular modules. So we have a antivirus signature database here. We have an anti-spyware signature database here. We have a vulnerability protection database here. We have a URL related database here. We have a data protection related here, file protection here, right? We have a wildfire database here. So what used to happen now when this data, so what all these particular modules, what they will do, they will load, they will basically load this particular layer 7 information from these memory location together just in one go, and they will just uh, match this particular database against the signature data. They will match this particular data or this layer 7 information against this particular signature database, and what they will provide the result. If there is any vulnerability or if there's any virus or malware and anything, they will basically provide the result. So here if you have observed, here when Jaguar chip is doing the signature based matching in your packet, it is just doing the processing just in one go, right? Your packet is loaded once, processed, and it just got, and we got the result. It is a clean file, or like that data is clean, or it is having some malicious content. So guys, that's because here, see, it is doing the stream based signature processing, or it is doing the stream based signature matching for the data. That is your single pass architecture, and your single pass software architecture is applied at your content engine only. Just remember. And if you will see this particular wheel here, it's the same wheel basically, what I have basically denoted. Okay. So that's how the data has been processed by the signature match processor. And now guys, see, this is the single pass architecture, right? And if you will able to understood this particular thing properly if you will get the what is the multi-pass architecture. So this is the diagram of multi-pass architecture. In multi-pass architecture, what used to happen? First, your traffic is processed by the firewall access control list, means layer 3 and layer 4 information has been checked against the configured ACLs or rules by the other firewall. Then your packet, see, processing is happening with the firewall policy, packet is coming back. Now it is moving for the next check. Now this packet is going for the URL filtering related task. Coming back, again going, and now it is going for the IPS related policies. Coming back, then again going for the antivirus related policy. So if you will see here, this particular task is every time repeating or not. Repetition of the task is happening. And also if you have noticed here, first URL filtering is happening, right? Then IPS, then antivirus, means it is a serial processing. It is a serial processing. It's not a parallel processing, right? It's not a single pass software processing. It's a serial processing, right? One task, then next task, one, then next task, then next task, right? But in Palo Alto case, all this URL filtering, antivirus, anti-spam, they are happening just in one go. Packet is loaded in Jaguar chip and just got processed just in one go. Stream based signature processing. Now, now you may ask, why Palo Alto firewall devices can able to do single pass type of processing, why other vendors is not able to do? So for that, let's try to understand the Cisco architecture. So guys, first we will understand how the Cisco product portfolio. So guys, let's suppose in Cisco devices, you just want a layer 3 and layer 4 protection. In legacy network, what we have to go with the ASA firewall. So let's suppose we have a ASA firewall here. This is my ASA firewall who is providing the layer 3 and layer 4 protection. Guys, is this ASA able to provide us the protection from viruses, antivirus, malwares and all? No. And if you need, like, if you want like a spyware protection, viruses protection and the vulnerability protection, then you need a Cisco IPS solution. And if you want a URL filtering, then you need to purchase some of the proxy solution or maybe URL filtering solution, which is WSA, iron port device from Cisco, right? If you need a protection like a data protection, file protection and all, in that case, you have to purchase a AMP solution, advanced malware protection solution, right? Or it will also provide you the 0-day protection, like we have a wildfire feature in Palo. So guys, what used to happen? Cisco used to create a dedicated devices for all these particular solution. And if people basically willing to use the Cisco solutions, then they have to purchase series of devices from Cisco for different type of features. And the problem with this particular design, because guys, here each and every device will process the packet. And if each and every device will process the packet, will add some processing delay, right? Packet will face some processing delay, and also you need to hire a multiple network engineers. You have to basically purchase a multiple devices, so you have to pay huge cost. Then you have to pay the cost for license for multiple devices, right? You have to also manage the life cycle of your devices, so you have to pay some cost, right? There is a huge cost you have to pay with that particular solution, right? This was the previous solution, but nowadays, if you know, Cisco has offered one more very good solution called FTD. So if you know, guys, I'm not sure you are aware of that. FTD is a combination of Cisco ASA, Cisco IPS, and Cisco WSA, and Cisco AMP. These four device functionality they have added just in one box to basically add all these particular solution inside just one box. So what they did basically while creating this box, Cisco ASA code is known as a Lena code. This is the ASA engine. And this Cisco IPS engine is known as a SNOT engine. So what they did, they have taken the Cisco ASA code. On top of this ASA code, they have added the Lena engine, they have added the SNOT engine. Then they have added the URL filtering engine. Then they have added the AMP engine. So what happening when packet is going through, packet first go through with the Cisco ASA, which is Lena code. Then it will go to SNOT, came back to Lena, then it will go to URL filtering, engine came back to ASA or Lena code, then go back to AMP again and came back to Lena code again. And after that packet is going out. Because guys, they have not built the operating system of FTD from scratch. They have used the pre-built operating system or pre-built code of their OS, and they have added one code on top of another. That is the reason they have not able to perform the that is the main reason they are not able to perform the single pass software type of processing. That is the reason they supports the multi-pass architecture. But your Cisco ASA, this Palo Alto, they have developed their code from scratch. All the features they have put in a proper way. That is the reason your Palo Alto able to perform the single pass software, or like it can able to, it will support the single pass software processing of your packets. So that is your SP3 architecture inside your Palo Alto firewall, and that is your, and that is also known, that is your multipass architecture as well, supported by the FortiGate, checkpoint, and your Cisco devices. And guys, because of that unique architecture of your Palo Alto is leading the market, and its throughput is very high in comparison to the other devices. See, the Palo Alto architecture looks like this. Like you can see here, we have a dedicated Octeon chip, multi-core Octeon chip. Then we have a signature match processor, Jaguar chip, data plane CPU, right? Where we have a network processor. Then we have a dedicated chip at your management plane. I'm not sure why they are saying this control plane. This is the management plane, guys. Because according to me, Palo Alto have another plane as well, which is known as control plane. Okay. There is a three planes is there in, but for your information, you can remember control and data plane. So control plane is like a management plane, but according to me, there is a dedicated task of control plane, and this plane just is known as management plane, which they have mentioned as control plane. Okay. Now one more thing, let me just discuss, and after that I'll just wrap up the session. Let me just show you the advanced architecture, how the component looks like inside your Palo Alto firewall. So where is that one? Management plane. Where is this management plane thing? This is data plane. Yeah, this is the one. So let me show you how the exactly component is divided at the software level. What as how the management plane looks like and how the data plane looks like with regards to their respected services or respected daemons inside the PAN OS. And these are the main daemons. These are the main processes basically. And if you want to do the troubleshooting, you have to remember all this particular architecture, guys. Okay. It is taking too much time in loading. Why it is taking that much time? Even though I can get here as well, no, nothing I can able to see here. Sometime whiteboard used to create challenges. Let me close, let me open. Some problem with the syncing looks like. Okay. So don't worry guys if you will not able to remember this thing, but because see, they have mentioned control plane. So like in your Palo Alto firewall, we have a management plane, then we have a data plane, and we do have a control plane here. Okay. And also one more thing to remember. If you will see in your management plane, most of the processes, these are the daemons. Most of your daemons is running in your management plane. You can see the number of daemons in your management plane, and we just have a very less number of daemons in your data plane. And then we have a 3 daemons majorly which are running in your control plane. Now each and every daemon has a dedicated task, and we will discuss all these tasks and everything in your further classes. So this is how the actual architecture of Palo Alto looks like basically. Okay. So your management plane is not only doing your config management, logging, reporting. It will also manage all these particular daemons because they are running in your management plane. Okay. So management plane is also a very, very important component of your Palo Alto network device. Just remember. And the main daemon of your Palo Alto firewall is the master D. And one core of your master D is running in data plane, and one core of master D is running in your management plane. And after that, this master D has a connectivity with the system daemon, and this system daemon has a connectivity with all the other daemons. So guys, when your firewall used to start, first your master daemon will use to start, then master D core will start in your data plane, and another core of master daemon will start in your management plane. And after that, this master daemon will will basically instruct this sysd, or it will initialize the system daemon. And once system daemon start running, this master D will basically instruct the system daemon, or it will send the messages to all the other processes. So it will basically start all the remaining process because this is the father of all the daemons. And it will communicate with all the other daemons through system daemon. So system daemon is the mother of all the daemons. And master D is the daemon who is responsible for starting all these particular daemons. If there is any problem in your firewall, like let's suppose 2 or 3 daemons has stopped, then this is the responsibility of master D to basically restart them properly, or reinitialize them properly. So initialization of all these daemons done by the master D. Just remember. So guys, that's it for today's session. Like this initial access, we will discuss tomorrow when I will go through with the lab setup. So that time I will tell you how we can access the firewall, what are the things we have to do and all. Okay.